It's been a really busy few years for the United Arab Emirates space program. They developed and launched a series of satellites, and last year they sent the first Emirati astronaut, Hazza al-Mansouri, to the International Space Station. Now their gaze is firmly fixed on Mars, and the culmination of all their efforts is standing right behind me. It's the HOPE probe, which is destined to orbit the red planet.
What the Emirates Mars mission will provide is actual data throughout an entire year, everywhere in Mars. Now, why is that important? Climate change is one of the reasons that Mars has transformed, and understanding better the weather dynamics and the atmospheric changes on Mars gives us one piece of the puzzle on what happened to Mars, why has it gotten to the state that it's at today, and that will even allow us to better understand climate change on Earth and what usually and naturally happens when it comes to climate change. So eventually, when we send humans to Mars, this will provide us with a better understanding on what will be faced.
Reaching Mars will mean big changes for the UAE back here on Earth.
The UAE government wanted to see a big shift in the ecosystem that we have when it comes to building a creative, a competitive, and an innovative knowledge-based economy. And it looked at space as a mean to do that. And the Emirates Mars mission is the catalyst for that big shift and change.
The scientific instruments that will be gathering all this new Martian data include an infrared spectrometer to study the lower atmosphere's cloud systems, carbon dioxide cycles and temperatures, an Explore imager for high-resolution images and to better understand UV rays in the lower atmosphere, and the ultraviolet spectrometer, which looks at how quickly hydrogen and oxygen escape Mars's upper atmosphere.
It's about addressing our national challenges when it comes to water, food, and energy resources. And it's about generating that knowledge that will serve humanity.
We are working on finalizing all the different test procedures to ensure that the spacecraft would work regardless of the situation that it faces. And May of this year, we are shipping the spacecraft to its launch site in Japan.
I got to enter the clean room for a closer look at the probe with one of its engineers.
So we have a total of 3 low-gain antennas and 1 high-gain antenna. So this is mainly used when we are far away from Earth and we're trying to contact the spacecraft. We have 4 solar panels providing the main source of energy for the spacecraft. We have a battery that will store it for cases like when we don't have sun. At the bottom, we have 2 star trackers that's kind of telling the spacecraft where it is.
7 months after launching, entering Mars's orbit will be the next really hair-raising moment for the team.
The spacecraft will look away from Mars and point the thrusters towards Mars and basically brake. If we go too fast or too slow, we'll miss it. If we don't hit where we want, we probably hit Mars. So it's a really critical thing, and that's why half of the fuel that we have will be used during that phase. It takes 12 minutes to almost half an hour to talk to the spacecraft. So you're not commanding it, you're just programming it in a way, and autonomously it will say what it has to do, and we just crossing fingers that it's doing what it's supposed to do.
In a way, history will be being made 20 minutes before you know it.
Exactly, which will be a really long 20 minutes.
That's something unlike anything that we've ever dreamt or realized we can dream of working on. It's the final countdown. We're getting to launch in July. It's the challenges of getting into Mars orbit, and the exciting part is finding new findings, new science, new results.
We'll find out in July if the young Emirati scientists and engineers here will be one step closer to realising their hopes.